All right. Here we go. All right, current unit lesson 7. Well, lots of bells. All right, so we've got some new or further conditionals practice. That's not the right button. Let's try that button. There we go. Okay, so we get here, we hit run. Let's see what we got. Okay, so what's happening here is we are, we'll speed it all the way up, console logging these conditionals. Now, it makes 0 sense to ever have a conditional of is 3 less than 5 or is 3 equals to 5. You would never have something written out that way. You would have something like asking the question, is age less than 5 or is age less than limit? Something like that. You would always be comparing, at least one side of those would be a variable, because if they're both known, what's the point of checking? Okay. And the other takeaway is that we are console logging and the output is true. For this first one, for first question 1, is 3 less than 5? It is true. It's important to understand that this equates to truthness or falseness. It is not, this is not the word true. This is like the concept true. And that's what conditionals are dealing with. And I mean, I don't know how much value there is in continuing these things, but for the most part, this lesson is a lot of taking some verbiage, taking some written language, and typing out the characters that mean that. For here, like it shouldn't be that difficult. Is 10 less than or equal to 10? So 10, you don't have to do spaces here, but I think it helps. 10 less than or equal to 10. And we hit run, we should get a true. And then the last one is, and I need to scroll over, don't have enough pixels, is 10 minus 3 greater than or equal, greater than 3 star 3. And you don't need to put parentheses around things, but it doesn't hurt. Where the parentheses would go here and here and here and here, just making sure that every open parentheses has its closed parentheses. Like here, I have an error. It probably won't let me get it back. Yeah, it won't let me go back to blocks. And that's because this closed parentheses right here actually belongs to this first one here and not to the one that I meant to. So there's that. And that's all there is for this one. Let's go on to the next one where I think we actually use some variables. Bubble 2. So we have a couple variables at the top being declared and initialized. And I'd call them global, except this program has no functions to possibly have anything that's local or any sort of scope situation. They're just there. And that's fine. Okay, so here is what I was talking about before, where we are using variables in different ways to check for a true condition or false condition. Where here we're using both of these variables are numbers. We can do arithmetic with them. Score is 10, lives is 3. Is 10 plus 3 less than 13? It is not. 10 plus 3 is not less than 13. So the first one is false. Then it's asking, is lives times 3 equal to score? Lives is 3 times 3 is 9. It is not equal to score. So question 2 should also be false. And that's all we need to do is change or convert the text into conditional. Okay, is score minus 5. Score minus lives, excuse me, greater than 5. Not terribly difficult. Score is 10 minus 5. Score 10 minus lives is 3 is 7. Is it greater than 5? It should be true for question 3. And the last one is score times 2 greater than or equal to lives times 10. And whatever the result of that should be. Okay, so the key here is we're using variables to ask a question if a condition is either true or false. It's binary. It has to be one or the other. It can't be both, and it can't be neither. That's what binary means. Okay, so now we have a little bit more complexity where we are asking questions of two conditions separated by either ands or ors. The and conditional is two ampersands. The or condition is 2 vertical bars, which the vertical bar is shift / on your keyboard right above the enter key. And what that does is it allows you to check for 2 things. Either both are both things true or one of the 2 is true. Okay. If the center is an and, that means both sides of it need to be true in order for the whole thing to be true. And we are only worried about the entire thing, whether the entire thing is true or not. And in this case, this first one, we're asking, is fruit servings greater than 3 and veg servings greater than 5? Fruit servings is not greater than 3, which makes this false. And because it's an and, we don't even need to check the second one. The whole thing is false. There's no scenario in which the whole thing is true if this is false because of the and. And for the second one, is grain servings less than or equal to 4? Grain servings is less than or equal to 4. Is fruit servings less than or equal to 4? It is. Both of these are true. The whole thing, whole question 2 is true. And question 2 is true. Question 3, am I eating exactly 5 grain servings and any amount besides 2 fruit servings? We have not seen this before, I don't think, and that is the not operator. The exclamation point means not, and you will almost always see it as not equals to. Exclamation equal means not equal to, and you would think, well, why can't you just check if it's equal to and then do the inverse of whatever you want to do? But that's not always possible. And it's not always the most concise way of doing it, even if it was possible. But just know that you can check for something not being true. I don't know. It gets sort of clumsy verbally when we're talking about that. But here we are checking 2 things. And because it's separated by an or, we need either this side or this side to be true. And we equate the entire thing to be true. Or both. If both are true, it's true also. And what is our question? Is grain serving 5 and fruit serving not 2? And grain serving is not 5. So this side is false, but fruit serving is 3, which is not true. So that means this side is true and the whole thing is true. So question 3 is true. Now let's just convert these other sentences into conditionals and drag out both of my console log statements to type them in. Okay, am I eating exactly 3? What's going on here? There we go. Are grain servings? Come on. I think I need to refresh here. Give me a second. Anytime App Lab is acting funky, like not letting you put your cursor somewhere, you probably need to refresh. Okay, and so for question 4, am I eating exactly 3 grain servings? So is grain servings double equal to 3, or, which is shift / double vertical bar, and the other portion of this is fruit servings. Excuse me, or is fruit servings exactly 3? Okay, is grain servings exactly 3 or fruit servings exactly 3? And fruit serving is, so the whole thing would equate to true. So question 4 should be true. And question 5, am I eating 5 or fewer veg servings and any amount besides 5 grain servings? So veg serving, uh, 5 or fewer, so that's less than or equal to 5, and double ampersand, any amount besides 5 grain servings. So is grain servings not equal to exclamation = 5? And should this be true or false? Veg less than or equal to 5? It is. And is grain serving something other than 5? It is. Since both sides of this and are true, question 5 should also be true, and it is. Okay, that's it for that one. Okay, so here we have a basic clicker app where when you get here, it's probably in text mode because the way they give it to you is broken. And the reason why it's broken is because the conditional for the if statement on line 11 doesn't have anything in the conditional. I recommend just putting anything in there, literally, like a number, and it will let you switch back to block mode. Okay, now we can work on it in block mode and have a better idea of what you're looking at. Okay, so we have one global variable, it's clicks, and the only event is checking for when the star is clicked. When it is clicked, clicks goes up by 1, clicks gets clicks plus 1, and the output is set to the updated version of clicks. Okay, it's always going to be update the variable and then use that updated variable to update the display or run a conditional based on that updated variable. Here, we want a scenario where when the clicks gets to 5, if there are 5 or more clicks, to have it turn red, which that is what we need to put here. Now, it says add a watcher for like down here, but there's really no point because the way they give it to us, it's already keeping track of the clicks on the screen. So we don't really need to do that. We just need to write a condition where it will change the color of the icon to red if clicks is greater than or equal to 5. It says or more, right? 5 or more, greater than or equal. And now when we click it, the first 4 clicks, nothing, and then 5, it turns to red. So every time the star is clicked, it's running this and it's running this conditional, but not until clicks gets to 5 is this conditional true. So it just ignores it and then it runs it. And that's it for that one. Okay, all right, so let's refresh. That's what the answer looks like, in case you were wondering. Ouch. All right, so we want a scenario now where the star is red if the number of clicks is between 1 and 4 inclusive, and anything after 5 or 5 or more, it switches to orange. Now, it sets up with a triple conditional, like an if, else if, else if. But in this particular situation, the star starts off black, and we aren't even checking its clicks until there's 1. So we don't need a conditional for if the star is 0 or the clicks is 0, make it black. That's just where we're starting. We don't need to deal with it. We do need to deal with if clicks is between 1 and 4 inclusive, 1, 2, 3, or 4 clicks, it needs to be red. Otherwise, it needs to be orange. But this is another way of saying less than 5. Okay, so if clicks is less than 5, we want it to be red. So starting right away, we click, it goes to red. But when it gets to 5, we want it to switch to orange. And all we need to do that is add an else statement by clicking on the plus sign at the bottom of the conditional. And that will give us an else condition. And all we need to do is have another set property, orange. And we don't need to check for greater than 5, greater than or equal to 5, because it's already checked here. If it's less than 5, this will run. And the only other scenario, given the context of our program, is 5 or greater. And so it can go straight into the else. Like that. All right, that's it for that bubble. Bubble 6. Is this the one with like 5 conditions? Yes. Okay, so here we have a situation where we want the color of the star to change every 5 clicks. Thank you. So the way we want it to end up is where, starting the same way, less than 5 red, less than 10 orange, and we don't need to check for the range. Like, we don't need to say 5 greater than or equal to 5 and less than or equal to 9. We don't need to do the range because we're checking these in order. We will only get 5 through 9 if it doesn't get caught here. So it's effectively doing the range because we're checking. Remember, I guess mnemonic would be, if you're checking less thans, you need to start with the lowest number. If you're checking greater thans, you need to start with the higher number. We did this before with temperature. Is temperature greater than 100? Do this. If it's greater than 90, do that. And the order is critical. Otherwise, it won't work. But we need to add 1. Right now, we just have 4, 5, and then it goes to there. We need 1 for everything all the way up through, well, less than 30 will get us violet, and the else statement will be the pink. So we're at 10. Let's add 1, 15, 20, 25, and 30. Our else is still the pink one. We'll drag it down there. And for these, we just need is clicks less than, let me copy it, less than 15, is clicks less than 20, clicks less than 25, and is clicks less than 30. And then we just need one of these for each of those. And it goes orange, yellow, green, and blue, and violet. And now, if we run it every 5th click, it should go through. And there you go. Okay, most specific case first. If you're checking less than, start with lower numbers and vice versa for greater than. Okay, bubble 7, I think, is the one with the check for out of order. Okay, and yeah, if I were to put it back the way it starts, look like this. Okay, so the code as it sits, the star never turns orange, it skips it. The reason for that is the conditionals are out of order. We are checking for less than 15 before we check for less than 10. And so if clicks was 7, 7 should be the one less than 10. But so if it's 7, clicks less than 5 is false, it skips it. Then checks is clicks less than 15. It is, it runs this and ignores everything else. Okay, this is just another, the order matters. So we just need to flip the 10 and the 15 and put their respective colors where they're supposed to go. And I think a lot of you would be able to identify a pattern, even if you don't understand conditionals and else if situations where it's only going to do one and then skip the rest. You'd still be able to recognize a pattern. So yeah, there you go. Yeah, we're flying through this pretty good. Is this the cat one or the, okay. So bubble 8, the value of what they're explaining is dubious, and the way they are explaining it is clumsy. I will attempt to break it down for you. I'm going to comment out the second half of this because that is where we are supposed to do something. But up here is their example. So what's happening here is 2 variables are being declared. The first one is y gets 8. So y is a number, the number 8. Then there's variable x. X is a Boolean. It's getting the result of the question, is y less than 6? Y is not less than 6. The variable x is holding the concept of truth or false. Okay, it's not a number, it's not a word, it's not a list, it's not an object, it's true or falseness, which is a scenario where if you are checking for some type of condition, the example I always use is like a game over situation for some complex game where you run a function that checks for is a score this or score that, whatever, and changes the state of a variable, where the variable at the game starts would be like, is game over, gets false. And if you run that function that ends the game, is game over would be switched to true, and you would just use that variable to check whether the game continues. But here we are using that variable x as a true or falseness. And in this case, because y is not less than 6, x is getting the concept of false, and we are console logging it. Now, what's happening here is the same thing. Okay, with this here, now this wouldn't work because this is now referring to y that doesn't exist until after it, but whatever. Y is getting 8, and then there's a conditional asking, is y less than 6? If y is less than 6, x gets true, otherwise x gets false. And then console log the result of that. Both of these things are doing the same thing, and I don't know the point of explaining either of them, or why you would need to learn either of them at this point. Okay, the example is so far abstracted from any practical application that I don't know if anything is even going to stick. So we actually are going to skip the second half of this because it's not, doesn't really help. Okay, so let's go on to bubble 9. Okay, bubble 9 is a cat adoption checker qualifier. And when you get to it, it will probably be in text mode, the way others have been. Because the if is broken, again, I recommend just put a number in there on line 13 so you can at least get back to block mode. And now that we are there, we can look at what we have. We have a couple of variables that are being declared and initialized. They are global variables. They're at the top, and we can use them anywhere else. Age is getting 0 and money is getting 0. And the only event handler is when the adopt button is clicked. So the first thing it does is it hides both elements. Now, when the app starts, they're already hidden. But the reason why they're hidden here is because the app is designed to be used like a couple times through. So if the answer ended up being yes, and the yes cat was shown, the next time through, the answer might be no, in which case both pictures would be shown, and it would be kind of clunky, especially if one was on top of the other. So the function, the event handler function, always starts with hiding both of them so that only the correct one would be shown. Now, how do we pick the correct one? Well, they've given us a flow chart here, and it's really just a single question flow chart. And our conditional statement is actually written out right here. This is what we're checking. We're asking, is money exactly 40 and age greater than 14? Which is what we need to put here. Is money exactly 40 and $&, age greater than 14? Now, this isn't going to work. I mean, it will work. We'll get the no. But the reason why it's not working is because we are checking these variables, money and age, based on their initial value. We are not retrieving the user's input. We need to retrieve the user's input. And to do that, we're going to use get number. Just like get text would get the user's input from a dropdown or a text input and assign that to a variable, get number does it, but it retrieves it as gives it the properties of a value as opposed to the properties of a string if we did get text. Now, in this particular case, we are allowing the user to type in a text input a number, and we are trusting them to type a number instead of letters, which is a horrible idea. Normally, if you have an app where you're expecting the user to input a number, in order to prevent the user from breaking it, you would have either a drop down where all the answers, all the drop down options are numbers, or a slider would work as an input for a number, and that would keep the user from breaking it. But we're assuming they're going to do that here. So we need to get number. The problem is these get number and get text, you need to put them somewhere, which the way we are going to demonstrate it is with reassigning the variables. Both of our variables are going to get new values. Age is going to get the number from age input or age number, and money is going to get the number from money number. Now, as this code runs, they have retrieved the user's input for the value, put them in the shoebox called age or money, and now we can use those to test our conditional. So let's see what we have. Excuse me, let's try to get a yes. So yes would be age 40 and money 40 should be a yes. And money 20 should be a no. Money 40 and age 11 should be a no. Okay, and that's it. Key takeaways are getting the user's input, putting in a variable, and then using those variables as the conditional. Always reassigning the variables first, and then using the updated variables in the conditional. And other takeaways, global, local, but really, this could have been local because it's only being used here. The reason why you would make something global is so that different functions could use the same variables and change it and access it. But yeah, this works. All right, bubble 10. Oh yeah, we're definitely getting through this today. Fantastic. Excuse me. Bubble 10, we have a situation where we are not interested if the money is exactly 40. We want to check if it's 40 or more, which makes more sense. We want to know if the user has at least $40. The other thing we want to change is that instead of age greater than 14, we want to check if the adopter is a teenager. Now, this is a little more tricky. Let's go ahead and take care of 40 or more first. So let's just switch it to text mode. And if money is greater than or equal to 40, we want that side to be true. Now, the way they explain teenager, okay, prevent anyone under 13 or over 19. Now, this is using the word or, but it's actually an and situation. Think about what we actually want. We want to make sure the user's age input is between 13 and 19 inclusive. So the way you check if a number is in a range, it needs to be both greater than the small number and less than the bigger number. If you did greater than the small number or less than the big number, every number falls into that category of being greater than the small one or less than the big one. It needs to be both greater than the small one and less than the big one to be in that range. And you can't really check a not less than or a not greater than. You would just check the inverse. But remember, the inverse of less than is not greater than. The inverse of less than is greater than or equal to. Just like the inverse of greater than is less than or equal to. One of the two, if you're switching directions, one of the two needs to get the equals. If the condition you're checking is already less than or equal to, it's reversing it would just be greater than. Okay, because you need to account for an equal situation. Somebody's got to get the equal sign. Okay, so let's work on this condition, and we can just easiest to go into text. So we have money greater than or equal to 40, and our age needs to be greater than or equal to 13, and $&, age needs to be less than or equal to 19. Okay, this is what it should look like. The way you say it might be something like this. Okay, age greater than or equal to 13 and less than or equal to 19, but that doesn't work. You need, each condition needs to restate what it's testing. Okay, so you need to check age both times. Is age greater than or equal to 13 and is age less than or equal to 19? And because these are all ands, you can just write it out. All three of these conditions need to be true because they're connected by ands. It's when you start getting into like ors, like if you group this, if you group this or this way, okay, is different than if you grouped the or, grouped the first two and then had an or. You need a few more parentheses when you start trying to decide which or matters or which way the or is facing, sort of. I don't know if that's the right way to explain it, but as long as you're on ands, you got to be true all the way through. And so we don't really need to segment off any of these conditions. They all need to be true. So it's going to check money greater than or equal to 40, age greater than or equal to 13, age less than or equal to 19. And if all three of those are true, it will run yes, otherwise it will run no. Let's look at their test conditions. Okay, age 18, money 40 should give us a yes. Good. Age 12, money 50. Money 50 should give us a no. And just take my word for it, the rest of them are correct. Okay. Key takeaways are testing a range means both greater than the small one and smaller than the big one. So that's an and what are the other takeaways? I think that's the main one for this one. All right, bubble 11 is another one like, I think it was 8, where its value is dubious and its implementation is clumsy, but we'll take a look at it anyway. So we talked about modulo before, or mod, when we were talking about the lemons game, where we checked to see if the number of lemons the user collected was even, or if the number of lemons they collected was a multiple of 5, or how many more they needed in order to get to the next multiple of 5. Okay, so that's the mod operator, or modulo, modulus, whatever. Its symbol is a percent sign. Okay, that's half of the battle. The other half is knowing that it just means division, except the answer is not the whole number with a remainder or a decimal or a fraction. The answer is only the remainder. Okay, call it clock counting. Doesn't matter how many times you go around the clock, the answer is what number you end up on of the clock. Okay, so the way, if the first number is less than the number of the clock, it doesn't go all the way around the clock. The answer is that first number. What are some other truths? If the second number is a 2, you're really just checking even or odd, because any number divided by 2 with no remainder is an even number. If it has a remainder of 1, it's an odd number. The point of this puzzle is to use these 8 numbers in these 4 modulo things to have a particular output. This sort of problem solving, where you're given a result and trying to match together numbers to mod to each other to come out with that result, it's not really a way that you would use modulo in programming. It's kind of a backwards way of applying the concept. We'll just talk about it. Okay, so if we want something to have an output of 2, that means the first number has to be, or rather the second number has to be greater than 2. Otherwise, if it's 2 or smaller, the output is either 0 or 1. It can't be, it will never get to 2. And we could use a 2 for the first number and anything bigger than a 2 for a second number, because if the clock size is 7, you start at the top and counted 2 around, you only made it to 2. So the answer is 2, which is the second one. If we wanted the result to be 0, that means any even number mod 2. So if we did 10 mod 2, would have a result of 0. And another 2 would be, this is weird, how would you do another 2? 10 mod 4 is a 2, because 10 divided by 4 goes around twice with 2 left over. 10 mod 4. And I'm not sure if I'm using these over and over again. And we need another 0. 10 mod 2. Anything mod 1 has to be a 0, because anything divided by 1 is not going to have any remainder. So what are we left over? Did I have a 3 in there? 3 mod 1 should be a 0. Okay, so don't sweat it if you don't understand what's going on. Just know mod is the percent sign and it's division, except the only answer is the remainder. Clock counting. All right, bubble 12. Bubble 12 has actually 3 different puzzles or challenges. We're going to do all 3 of them. They are about 3 or 4 minutes each. They're not very long. If you finish the first one and hit run and it works and you hit finish, it will take you to the check for understanding, not back to this screen to select the next one. I am going to check them. You need to do them. Just because all your bubbles are green doesn't mean you're getting full credit for the lesson. You have to actually do the work. Okay, so that being said, let's jump right into the first one, chronotype, whatever it's called, sleep profile. So this app is designed to take the user's input of their bedtime, their wake time, and their sleep type, either light or heavy, and assign them sort of personality traits for one of 4 different animals. Okay, so they already have drop downs for bedtime, which is somewhere between 8 and 12, and wake time somewhere between 4 and 11. We're assuming AM, and then a binary situation for light or heavy. Click on the button, and you will get some animal that you are most closely related to. Now, the way it's given to us, it is incomplete, because our logic table is right here, where each of the 4 animals has a bedtime, a wake time, and a sleep type. The first one, the dolphin one, is already done, and it is correct. You could see here the dolphin combination. I don't know why they did it out of order compared to the logic table, but that's fine. Sleep type, light, bedtime, greater than or equal to 11. Anything that's or later is a greater than or equal to. And wake time, 7 or earlier. So that's a less than or equal to. Okay. Let's look at the rest of the code real quick. We have 3 global variables being declared at the top with no initial value, which is fine. Bedtime, wake time, and sleeper type. Then we have our long event handler. Then we have 4 variables being declared at the bottom. It is super rare. In fact, this is probably the first time I've seen an example where variables were declared at the bottom of a program. Normally, that would be the wrong way to do it, and I think it may actually be the wrong way from a education standpoint to show you how variables work, but it still works because the only other part of the code is this event handler, which is like a function that only runs on the event, which means this code is run and this code is run before the event handler. So it works out the same as if these were at the top of the screen. I guess they're just there because they're take up a lot of space and are not super not relevant, integral to the logic of it, but they are just 4 variables that are holding these long URLs for the images. For the images that are used as the icons here. Okay, so all we need to do for this to work is to change the conditional statements so that the wolf will be run when it's supposed to, and the dolphin will run, and so on. Okay, so let's look at the conditional table. So for wolf, we need bedtime, midnight or later, wake time after 7, and sleeper type either. So for wolf, the easiest way is to just get rid of the conditional that's there, and then we'll just type out these statements as conditionals. Okay, so first one is bedtime greater than or equal to 12. Because our options are only up to 12, you could have equal then, or just, double equals. In this context, it doesn't matter. We don't have any situation where the user could put in 1 a.m. and be able to check that one was greater than 12 because it is later. You could write a function to convert AM and PM. But either way, just as it's written, bedtime greater than or equal to 12 and double ampersand, wake time after 7, so that's greater than 7. And for sleeper type, since it's either, we don't even really need to check it. You might think either is sleeper type double equals and then light in quotes, or sleeper type double equals heavy in quotes. But since contextually those are the only two options, we don't even really need to check for it, which I think is a lost opportunity for the curriculum to work on some OR stuff. But yeah, there you go. Then for lion is this. So first one is bedtime. 10 or earlier, so that would be less than or equal to 10. And wake time is wake time 6 or earlier, so that's less than or equal to 6. And again, we have an either situation. And there's that. And then our only other scenario is bear. And it runs in an else. And even though I haven't worked out every possible combination of bedtime, wake time, and sleeper type, I'm guessing there's no scenario where it could skip all of them. Where if there was a scenario where it could skip all of them, we would need a different else, or just end in an else if situation. But here, we're just going to stick with bear as our else. And I think everything else is fine. Yeah, we're getting number, getting text. So, excuse me. So let's test their conditions. 12, 8, and heavy should be wolf. 12, 8, and heavy should be wolf. Good. 11, 6, and light. 11, 6, and light should be dolphin. Excellent. 11, 8, and heavy should be bear. And 10, 6, and light. 10, 6, and light should be lion. Excellent. Okay, works. Great job, everybody. Okay, click on bubble 12 again at the top so we can get back here. Okay, so here we have a music genre picker app that is using a flowchart as its logic basis instead of a table like the last one, which is fine. I think it actually makes more sense visually. And this flowchart is their existing conditional, which is right here, and it works. Okay, the first thing it's checking is volume soft, and if it is soft, it goes here. And because this is the only scenario, if it's true, that can be its own if statement, because that will end checking for anything else. But if it's false, it can go to this question and ask, is activity go for a drive, which it is or is not, and has to be one or the other. I think this is a lost opportunity to explain nested loops, or excuse me, nested conditionals, where, so this first question either has to go left or right. If when it went left, it had another question with 2 answers, along with this one, you would have an if-else statement here, and then the if would have its own if-else, and the else would have its own if-else, to have 4 paths of which to choose from. and you would have it set up that way. You could have a bunch of like ands, like this first condition and the second condition, this first condition and the second, this first and the second and the second. But showing it as a nested conditional, I think makes more sense as far as like paths being the answer to whatever the result is. But for this one, it does work as just this basic else if situation. All we need to do is change it so that it applies to this flowchart. So we just need to ask these questions. Okay, so the first one, instead of volume is soft, is activity. Activity is workout. It is pop. And if volume is soft, it's classical. Otherwise, it's country. If volume is soft, it's classical. Otherwise, it's country. And there you go. They don't give us a oh wait, activity. What did I do here? Activity, is it, did I misspell it? Oh, never mind. And there you go. Okay. Yeah, I would have liked to have worked through a nested conditional, but yeah, here you go. The only reason this works is because the first question, one of its answers ends the flowchart. If the flowchart kept going, we would need to add to it either with the compound conditionals or with a nested conditional. But that works as is. Okay, and the last one, fizz buzz. So this one is similar to the cat adopter app, where it's checking for some condition and showing either one or the other images. Okay, and it's taking a user's number as an input and checking whether that number is divisible by 3. If any number mod 3 is 0, that means it's divisible by 3. You were able to divide it with no remainder. And any number mod 5, if that's 0, means it's divisible by 5. And based on which one, if either is true, it would run one or the other. But we want to, okay, what if here? We want to set it up so that it checks to see if it's both divisible by 3 and 5. Now, of course, that means we need to add a conditional, excuse me, add a condition. But the thing is, this check for divisible by 3 and divisible by 5 has to come first. It is the most specific scenario, because if you had a scenario down here that was checking for divisible by 3 and divisible by 5, it would be caught up by this one first. Because if it's divisible by both, it is divisible by 3, and it would never get there. That's why we need to put the most specific case first. The other thing is, the way it gets here, you'll notice that when it gets here, or when you get here, it starts out with an if and an else if. That doesn't end in an else, which makes sense. If the user put in a number that is not divisible by 3 or divisible by 5, nothing is going to run. If it ends in an else, something is going to run. If it doesn't end in an else, there could be a scenario where it doesn't run anything. So in order to get another conditional, we actually have to hit this plus sign twice and then back one so that we have 3 actual conditions and the last one isn't an else. And like I said, our new scenario has to go first. So we're going to drag all these down to free up the first condition. And what is our condition? If we're checking for both to be divisible, that means is number mod 3 double equals 0 and is number mod 5 double equals 0. And if that's the case, we want both the fizz and the buzz to show up. Wait, what happens if we have both texts? And what do we want? Oh, we also want the text to say fizz buzz. If you set the text twice, it will just show the last one. Okay, so if we do, let's do 27, it should only be the 3, 10 should only be the 5, and 30 should be both of them. There you go, fizz buzz. Most specific case first. Asking number twice, number mod 30 and is number mod 50. And that's about it. Okay, the last two are a couple of simple check for understandings. They are just multiple choice pseudocode situation. And let's take a look at them. Okay, so practice question. What will run after the code segment is run? Okay, so we get a couple of variables. Score is 4, live is 3. And it is important to be able to understand, and this is an example of a nested conditional where we have an if-else and another if-else. It's pretty easy to see which condition the else's belong to. These two are related and these two are related. And pseudocode has these nice boxes, but we'll solve this in a second. When you get to the next one, you'll see that the code, this is actual for real JavaScript, or possibly some other things. It's not as clear which if the various else's belong to. You need to be able to visually line up which conditions are justified or indented the same amount, because those are the ones that are related. If you're not used to looking at actual text program code, it's something you're going to need to figure out. And yeah, so this if and this else are one of the conditions or one of the conditionals, and this is the other one. But let's go back to the first check for understanding and solve that. Okay, so score is 4, lives is 3. Let's check if lives is equal to 0. Is it equal to 0? It is not. So that means we're running this. When we run this, this introduces a conditional, an if else. Is score greater than or equal to 5? It is not. This is false because it's an and. The whole thing is false, which means this has to be run. So you win is the answer for this one. And if your AP test is on paper, it's not terribly difficult to get out a pencil and trace it. I would say probably bring scratch paper regardless, so you can, just follow the same way I did with the pen. It's not that difficult. Okay, for this one, our goal is to come up with a possible input for number that will give us the result cold. The result cold is down here. In other words, how do we start here and make our way down to there? What do we need to put in? So like I said before, this if and this else are related, and this if and this else are related. Okay, if the number is greater than or equal to 10, this is true, and it means we need to run this code. But we don't want to run that code. We want to make it all the way down here. So we need a number that is not greater than or equal to 10, otherwise known as less than 10. And of the options, the only one of these options that is less than 10 is 5. Okay, and that's why 5 is the answer. Okay, if you have any questions, let me know. This recording should be up shortly. And if not already, if you're listening to it from the recording. And yeah, that's it.